We've learned about three major processes: isobaric, isochoric, isothermal, but there is one more important, because that process, the fourth one, is a part of that best cycle which Carnot invented to prove that the best efficiency for any engine is only related to two temperatures, the highest and the lowest. That additional process has a name: adiabatic process. It happens even faster than isothermal. This is a Carnot cycle. We don't need to know the equation for that process. We only need to know the definition. The definition is, during this process, the system does not exchange heat with the environment. And Q equals 0. We have two options when that might happen. Number one, Q equals 0. And in addition to that, there is no work at all. That's an old-fashioned heat balance equation. Heat exchange happening inside the system. That's it, nothing else. But there is an option number two, when the process is happening very, very quickly. Like a collision. There is no time for the heat exchange. In that case, Q still is equal to 0 by definition, which means the change in the internal energy is directly related to the work done by the gas. But who likes minuses? No one likes minuses. So instead, we can switch it back to the original work done on the gas. If we do some positive work, the change in internal energy should be positive. That means the temperature should rise. And if temperature rises really high, it actually may be higher than temperature required to put a paper on the flame. So I have tiny pieces of paper here. I put it in this cylinder with very thick walls. Why do we need thick walls? To prevent heat exchange. And I have a piston, so first I want to push these pieces of paper inside slowly to bring them down. See, nothing is happening. Of course, I feel resistance, pressure is increasing. Now I want to make this piston move very, very quickly. Newton, we need your help. Thank you, Newton. And thank you, world, for our existence. So, what happened? Because my process was very, very fast, all my work, it's the amount of work I've done, transferred into the internal energy of air, and the energy jumped, and that led to a jump in the temperature. And temperature inside the cylinder became so high that it put paper on fire. What's going to happen if we do something opposite? You know what it is. Don't forget to take out the pin and press. Why is it snowy? It's fog. Because when it expands very quickly, gas expands, the temperature drops. And when the temperature drops, water molecules in air become snowflakes. That's how Newton makes snow.